What's up, everyone? It's Sad Nixon, and I'm going to be going through my code that I use to calculate the odds of winning for each team in the tourney all throughout the tourney. So this is a piece of code that I wrote for last tourney, the fourth SH tourney, and then I used again for the fifth. And yeah, it's a pretty big piece of work. I put a lot into this, so yeah, hopefully you enjoy. Now, first off, I want to say all the data from this comes from some spreadsheets that I created. Um, there's basically two spreadsheets. Number one is this spreadsheet, which is very important, which has each player, their elo, their team, their role, and how many games they've played. And a lot of this info is imported straight from the main tournament sheet using this import range stuff. This stuff and this stuff is kind of automatically updated, which makes it really fast for me to get the data in once a game is completed. The elo data is not. The elo data I had to get manually from drafting data, and that was a pain, but I did it. The other sheet that I use is this sheet, which also imports directly from the tournament spreadsheet, which has each team, and then it imports their points and their wins, which are both relevant, of course. So yeah, obviously that's what we need to do our simulation. So if we go into the code, what do we got? Well, first of all, the first thing I defined when I made this code is basically the formula that tells us how much of the time one team is expected to beat the other team, given the elo formula. So this is the lib win formula. This shows us how likely the libs are to win. Uh, yeah, so this is just the basic elo formula that you can find online. Um, this is an example of what if a team of all 2200s face up against a team of all 1400s, which is it would be a 99% win rate. I'm not sure if that's accurate for Secret Hitler because there's a lot of RNG, but like maybe. I mean, 1400s are pretty bad. 2200s pretty good. So if that ever happened, which would be very unlikely, maybe that would be the case, but who knows? The next part is just importing the big sheet. And in this stage, we add another column that shows remaining games. So one of the most important parts of the sheet is the part that shows how many games each player has played. And then we add another column here, basically using this code that adds in how many games they have remaining in the tournament. So that tells us what are the possible players that could be playing in these upcoming games based on how many games they've already played, right? So this accounts for being captain and vice captain, of course. But you can see that Tice and Line Lizard have, played 4 games, but they have one more. Whereas Alex Corpus has played 2 games, but they have 2 more. So yeah, it counts for that. Moving on, I have to make this big kind of order of each kind of game. This is important because it tells us how many points each game is worth and other stuff. In this tournament, this was the order. We can see we have regular games, board games, voice games, one silent game, special games, all that good stuff. And then I defined a nice list of roles. This is, every game has 4 libs and 2 fascists and 1 Hitler, so that should be pretty self-explanatory. Next, we have to define the concept of a team. So I actually used classes. I made a class for team, and this is this is a lot of really screwy code. Turns out this is harder than I thought. Basically, what we have to do is we have to input a name and a number of points and a number of wins, and that's the number of points and wins that a team is at, kind of at the point where I'm running the simulation, and that data is all stored, right? And then we import, basically using the name, the people that are in this team from the main player sheet, because we find every player where the player's team is the name of this team. That's what happens when we define a new team. And then we have this function for order, and what this function does is it finds one possible order of players that could play from this point of the tourney onwards, from the start game onwards, we say, based on the data of who is remaining in the tournament and what kind of games they can play. So this is what it does. So it looks through and it finds, okay, for each of the people that are on the team, it puts those people into a big list, but it gives, duplicates into that list depending on how many games they have left. So this is how it accounts for, people that have 4 games left. They could play more games than people who have 2 games left. And then it does this loop that tries to figure out a valid arrangement of people. And This is kind of a weird shortcut way to do it, but this is the best way I could find. So basically, it randomly makes an arrangement, right? And then it goes through and it figures out, okay, for these four games, for games 25, 28, 31, 34, whatever, those are elo max and min games, so those games can only have certain players in them. So then it has to find a person who meets that criteria and places that person in that game. But then it has to check to make sure, okay, in doing that, uh, did I give a player too many games? Did I give it more games than it's allowed? And if it meets all those checks, and if, and this is crucial, it meets the criteria of, okay, are all the players that are going to play, does that cover all the players that still need to play a game? Because every player has to play one game. So if it meets that check as well, which is this code here, it uses set notation, um, then yeah, then it says, okay, this is valid. And it kind of, if it fails, if the random generation fails, which it can fail because of the way I've done it, it's not guaranteed to work. Then it just tries again. And that's kind of a really probably inefficient way to do it, but I couldn't find a better way to do it. So if you know a better way to do this kind of thing where you're trying to make a random arrangement but with some constraints, then let me know, because this is, yeah, this was hard to figure out how to do. And then there's also a function here that just kind of wipes the whole team back to its initial state. So we want to be able to, after we figure out a simulation for a team, we want to be able to put the team back to normal, kind of put the points back to where they were at that point in the tourney and the wins. So that's what that does. That's all it does. Um, then we have this part which actually imports all the team info. So this is looking at this sheet that I just showed you, this sheet number 2 here. And then it is kind of importing that into defining each team. So it defines all 7 teams based on the info. Boom, 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 boom. This all uses pandas, by the way. If you know what that is, it's a Python package. Um, and then it puts the teams in a list. And this is some leftover data from last tourney, but yeah. And then this is another big crucial part of code. This is the game code. So this simulates each game. So it imports all the teams, puts them in a team list, finds the player that will play for that game based on which number game that is, and which, the order of players that each team has generated at this point, because at this point each team has generated an order of players. Boom, boom, boom. It puts those guys in. It sorts them out into their teams based on assigning roles. Basically, it acts like, these players are always in the same order based on team number, and then it kind of assigns the roles to those seats in a way, which is different than seats in the game, but it works. Um, and yeah, it figures out the average elos for the two teams, um, and it figures out which teams are on each lib and fascist team, and then it figures out which game type this game is based on the big list of game types that we saw earlier. Now, if the game is a regular game, then we are going to do a random roll of the dice and compare that to the win percent of the lib win. So basically, remember the lib win formula finds out based on elo what percentage of the time the lib should win. And so if the random number, which is between 1 and 0, is below that number, then libs win. If it's above that number, then fast win. So yeah, obviously, when you win a game, it gives your team 1 point, 1 win point, and 3 points in the tourney. And so it says, for F and fast teams, we do that, blah, 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 blah. If it's a special game, it's the exact same thing, but with 5 points. If it's a silent game, now we have to loop 3 times a game, and we have to assign a third of a win and 1 point for each of those. Now we also basically we do this thing, yeah. So then this is the part of code that accounts for the fact that if a player wins, 3 times, then they're going to get an extra point. Yeah, so that does that. And then for every other kind of game that isn't either a regular, special, or a silent game, it's just a 4-point game. Elo, min, max, and voice games and board games are all that. So it just has the same code as above, basically. And then this is the code that actually runs the simulation. So we start out at a certain game. So this is starting at game 47. So this is the simulation that I ran right before the tourney ended. And then it creates lists of the amount of wins and second places and third places and last places that each team gets. This is each of these is a list of kind of 7 zeros to start with, and then it says, okay, for K in range 20,000. And I did 10,000 at first for the first few days of the tourney, and then I switched to 20,000 because we had less games to play, so I could kind of afford a little bit more accuracy, and not have to run the simulation for a billion years. So it sets each team to their starting place. It finds an order for each team, right? And then it puts those orders into the games and it just runs the games, all the way up to game 48 in a loop. And then after that, it figures out, okay, how many points and wins does each team have? Let's sort the teams by points and wins, which is how we tie break. We tie break points by wins, and then it finds out, okay, um, which team is in first, which team is in second, which team is in third, which team is in last, and it adds those first, second, third, and last kind of scores to the lists up here that have each team's first, seconds, thirds, and lasts. Yeah, and then it repeats that process obviously 20,000 times, or 10,000 or whatever, and then it has this code that kind of prints out the data in a nice way. Um, Finds the percentages, and this is what I was copy pasting onto Discord when I did each round. And this shows at this point right before the last two games, Pinku had 62, Hemi had 33, and so on. Mexicans and 4-4 had no win rate at all. That's reflected in the code, obviously. And yeah, that basically sums it up. So very sophisticated piece of code. There is room for improvement, right? If I can find a kind of better, less contrived way to do this, I might. I also might add in some stuff that kind of assumes that whoever's in the special games will be of high elo, because this is generally true. We had very few non 2K players in silent in special games. I mean, this time. Um, I was in a special game, but that's a big exception. There was, I think, one 1900 player, etc. Um, I also kind of want to add something that accounts for players' records in the tourney. So, if a player's doing really well, they're kind of on a hot streak in the tourney, maybe they should, get a higher chance of winning their remaining games. Maybe I should also account for the fact that, captains don't randomly put players in orders. They weight heavily towards the higher elo players, the better players. So I could account for a bunch of different things that aren't accounted for yet. Let me know if you have any suggestions for next tourney in terms of things that I could account for, things that I could code into this. I really want to make this better. I think it was already pretty good at doing predictions. It gives you a good idea. But of course, it could always be better. So yeah, let me know.